we're recording.
Okay, hello everyone. So my name is Guylaine. I'm an application scientist at Indic Labs and I'm based in Switzerland. As Natasha mentioned, I will run through multiplex EHC, EHC and the FISH IF module today. I will pause between parts for you to ask questions. And if you have any question during the training, please feel free to interrupt. Or is there any comments someone would like to make before I start? All right, so I will be starting then. So the algorithms we are going to touch upon today are all meant for cell segmentation, and each one of these are used for certain applications. So multiplex EHC is meant for cell segmentation according to protein markers in bright field, and the ISH EHC and FISH IF modules are meant for probe segmentation, but also have a component for protein markers as well. And the ISH EHC module is used in bright field typically, and the FISH IF module is used in fluorescence. So I probably start with the multiplex module. It's just because it has a lot of similar features with the two other ones, and it contains slightly more parameters. So it will give us a good basis to understand and use the ISH EHC and FISH IF modules afterwards. So one thing I usually recommend is to start by going to the help button and look for your algorithms of interest. So here I've already opened the multiplex algorithm, so I'll probably just click on that for now. And you see that the multiplex algorithm user guide is a step-by-step guide that has a lot of information, a lot of screenshots, and will guide you really step-by-step through the use of the algorithm. I'll probably recommend having a scroll through this at the start, and you'll find at the bottom very useful information, such as the input parameters, which will allow you to understand better how to set and tune your parameters at the start. And you'll find also the output parameters at the bottom, which will explain to you how to read your results from the results tab. All right, so we'll go through that today, but this is just a quick note for you if you ever are wondering about those parameters. Okay, so I'll go back to the multiplex algorithm. So here we have an image which is quite interesting because it has 4 stains. And I will go through this, the tuning of the segmentation of the cell segmentation here, just to show you what the program can do. And in that case, for example, the 4 stains are hematoxylin, a pink stain, a teal stain for membrane, and a DAP stain for nuclei. And in that specific case, the hematoxylin is quite faint, so I can show you how to recognize your cells, even though your hematoxylin stain might not be ideal. And I'll show you over more parameters. Okay, so the first thing you want to do is to go to Analysis Magnification. One thing to note is that every time you're going to click on each of these boxes, you'll find some text here at the bottom to explain to you what each parameter is for. An image zoom of 1 means that you're running your analysis 1 time the maximum magnification of your image. So if the image was, I think here it's 20x, if it's 20x in that case, it means that you're running your analysis at 20x, which is usually fine for EHC. If you are using ISH, however, we recommend scanning and analyzing at 40x. All right, so this is something that you should definitely do at the start because it will change the way you're recognizing your pixels afterwards. So please do this at first and try not to go back to that as it will modify everything. The next one down is the stain selection. So this is common to most of the cell segmentation algorithms for bright field. And as you recall, in the first training, we used cytonuclear. And you'll see that those steps are actually very similar to the cytonuclear module. But it will differ in the next parameters. The first thing you want to do is to set the number of stains you're going to take into account. So for today, I will take into account fringe stains, as I will not take into account the hematoxylin stain. And you want to give them a name. So the stain one will be my DAP marker. The next one, probably the teal one. And the last one, the pink stain. And the next thing you want to do is, similarly to cytonuclear, is going to the color selection window and select and pick a stain of interest that is representative of your DAB nuclei. So I could probably go here and select that. You see that I can zoom in and out. And I can also go on the sides using these arrows here. Once I'm okay with this, I'll press OK. And I'll proceed to the same steps with the teal stain. So I can click on that, zoom in. We recommend having about a minimum of 9 pixels in general, just so that it's representative and you're not basing your entire analysis on really few pixels. Press OK, and I'll do the same for the pink one. So maybe I can go here, zoom in. You can also zoom in and out with your mouse wheel, as you can see now, and press OK. And there are different things you can do from here. So when you're using when you're using fluorescence module for cell segmentation, you always have the option to ignore and just include or exclude some dyes in your analysis. For bright field parameters, it's a bit different in the sense that you can choose to ignore or exclude some stains from your analysis, but the thing that you will always have to do is to select them at first. And this is basically to help the program deconvolute your individual colors. So imagine that I didn't want to now analyze the pink stain. I could set the pink stain as an exclusion stain by selecting pink here. And basically, if I had not done this, the program wouldn't probably know, would probably take some of the pink stain to recognize the other stains. So this is something that you should definitely take into account. So for now, I won't pick an exclusion stain, but keep in mind that this can also be used to remove maybe debris or precipitates that are interfering with your segmentation. And the next thing you can do is to set a number of phenotypes. So you can use the slider here and add up to 30 phenotypes here. And you see that as I use the sliders, some phenotypes have been populated down here. I can also set a number directly. So I'll set this to 1 for today, just to give you an example. And the next thing you want to do is to go to Analyze and go to the real-time tuning window. So you see that the program is already starting to do something. It's already trying to segment your nuclei. And the reason for that is because my first stain input here is a nuclear stain. So make sure that your first stain is your nuclear stain if you want this queue to be taken into account by the program automatically. Otherwise, you will have to change this manually. All right, so the next things you can do is going to the deconvoluted image of every of your stain. So this helps you really appreciate how the program is recognizing each stain. So here it's doing quite a good job to recognize the DAP stain. Here you can see that it's doing a good job as well to recognize the teal stain on its own. And it's pretty good also to recognize the pink stain. So this step is actually crucial if you want to have a good quality segmentation, because it will allow you to see if there is any stain that is bleeding out into another one and interfering with your image here. And this is very important because you will base all your next parameters on this. So make sure that this is actually accurate. And the next ones are the next things you can see as output images are your single stain markups. So here you might see something for the DAP because it's the nuclear stain, but if you go to the other ones for now, you won't see anything just because we haven't set these parameters just yet. So I'll just go back to that markup and I'll go to now to the nuclear detection section. So here, the three first lines you will see are designed for the detection weights. So you have a line for every of your stain. And what the program will do automatically, since the DAB stain was input first, is to set the DAB nuclear detection weight to 1. What does this mean? It means that the program is fully taking into account the DAB stain to recognize your nuclei here. If you had any other nuclear stain, you could give it a weight as well. But this doesn't apply for the teal because it's membrane and for the pink because it's cytoplasm. So I leave this to 0 for now. And the next parameters are basically set to detect your cells and segment them. So the first one you have is the nuclear contrast threshold. And basically it will be to eliminate objects which have very diffuse or fuzzy boundaries with the background. And it's very sensitive. So usually, typically, if you go too low, what you'll start doing is selecting areas which have low contrast with the background. And if you go too high, you'll start picking only areas which have high contrast with the background. So I'll probably recommend to go to an area which is, well, a good compromise. And maybe from here, since it's quite sensitive, use your mouse wheel because you see that small increments are really changing a lot the way the program is recognizing your cells here. All right. One thing I like to do is to go here under this in the toggle analysis tool here and set the transparency higher, just so I can see my nuclei under the markup and see if what I'm doing is all right. And think about this parameter not as a linear step-by-step thing, but rather as a compromise. So all these parameters will work together towards an optimal segmentation. So just make sure that you go back and forth between those in the best way possible, just to see if this is working or not. So even if your parameters are set at the beginning, not in the optimal way, it's not a problem because you can always go back and forth and see what's the best fit. So one thing typically I like to do in that case, for example, is to jump directly to the nuclear segmentation aggressiveness. So this is basically meant to segment interconnected nuclei, but it will also play with the way my nuclei are segmented. So usually what I try to do is to play with this parameter, maybe increase this parameter when I want more segmentation. And just go back to the nuclear contrast threshold to see if I can find a better, maybe can lower this to have to get more of these nuclei that are kind of fainter. Okay, I can increase this a little bit, and you see that as I increase this, I start to. So you see that I start to create boundaries between these interconnected nuclei. So here I've created some boundaries. All right. And I can always go back to the contrast threshold, maybe make it a bit smaller, just to get more of those. All right. And if you have some objects that are recognized as nuclei when they are actually not, there are background objects that are counted as false positive, you can go to the nuclear optical density, minimum nuclear optical density. And this is basically the absolute value for which you can start recognizing your nuclei. So if I go lower, I will start including some areas with lower optical densities. And I can also use that to get rid of false positive objects from my background if I wish to. So adjust this as you see fit. Obviously, on your own images, you can take more time to optimize this. I think this result is not too bad, so I'll move to the next parameters. You can adjust your detection according to nuclear size. So you will have typically two sliders here, so a minimum and a maximum size. So you can adjust these sliders directly by clicking on them, or you can add a value before and after the comma. So I like to put maybe 5 to get also the small tiny nuclei as well. You can also detect objects according to their roundness or exclude them. So if I had very long shapes, by increasing this, I could also get rid of these longer shaped nuclei. But this is really something that you should use carefully. And the last one is the filled nuclear holes. So in the case of having a very faint staining in the middle of your nuclei, you could have some holes in your nuclear detections that might over segment nuclei. So this doesn't really apply here, but if it were the case, you could set the filled nuclear holes to true, and this would typically fill the holes and make sure that you are getting only one nuclei in the end, not maybe 2 or 3. All right, so of course, I recommend to move across your images and just see if it's working for the rest of your image. And you can then go to the membrane and cytoplasm detection. So basically, this the first thing you want to do is to set a maximum cytoplasm radius. So if I set this to 3, for example, you've seen that a cytoplasm has been dilated out from my nuclear shape and is now of a 3 micron radius. And an interesting thing that I've mentioned earlier is that if you cannot base your analysis only on your nuclear stain, you also have the possibility to base your segmentation on membrane stain. So at the bottom here, you have 3 lines per stain, and you can assign one of these stain a membrane segmentation threshold. So if you go to the TIL membrane segmentation, for example, and set it to true, you'll have the option by going back to membrane segmentation aggressiveness to take into account this TIL stain for membrane segmentation. So you'll see that I'll probably make it less transparent just so you see it better. And what the program will do is take the cues of the TIL stain to start recognizing your membranes. So here, in that case, you see that it's adjusting to the TIL stain. So maybe I might increase the transparency just to see if it's corresponding to the membranes. All right, I think it's pretty good. So you can always toggle this on and off to see if your membranes are correctly matching the TIL stain. And if it's all right, you can leave it as is. And you can go to the next parameters. So each of these parameters will be meant to assign a threshold for each compartment of your cell. So this seems a bit complicated at first glance, but in fact, you're just having the same parameters 3 times, depending on the cell compartment you are in. So nucleus, cytoplasm, or membrane. And for each of your stain, most of the time you will, of course, have only one of those two sets. So for the DAB stain, I'll just go to the DAB nucleus positive threshold and just ignore the other ones. And if you ignore the other ones, they will basically be ignored from the results as well. So you just don't touch them and you will have only the results from the nucleus. The first thing you can do is to set a different color if you wanted to. So maybe I can set this to an orange color. And typically, if you go to the cell markup and go to if you go to the cell markups, you will look at this color here. And typically, the first thing you want to do is to go to the positive nucleus positive threshold, and you see that you have 3 sliders here that are separating your 4 categories of signals. So the first slider will make the difference between negative nuclei and weakly positive nuclei. So if I start going down now, I'll start picking recognizing my low positive cells, my low positive signal from the negative signal. So you can move and see if it's working everywhere. And the next thing you can do is use the next slider to set a threshold between the weak positive. Okay, so all right. Just one thing, of course, I set the cell markup here. So when you're going into cell markup mode, you're not looking at your actual thresholds here. if you want to look at these thresholds, you would have to go to the DAB markup because it's specific for your DAB markup. So if I go here, I typically have these colors now. So my first category is negative, so it's nothing. Then you have the weak positive, which is yellow. Now I've just created a moderate positive category. And if I lower this slider, I will create a strong intensity category as well, as you can see in the red here. And this will basically help you generate H scores automatically in your results. All right, so if I were not interested in this, I could just set the first slider only and leave it as a cell markup. All right, so I will go to the teal stain and do the same. So here I have nucleus, cytoplasm, and membrane. I'll go directly to the membrane. By the way, there is this other parameter that I've not mentioned yet. I will mention this afterwards because this doesn't really apply in those cases. All right, so I go directly to the teal membrane positive threshold and do the same thing. So maybe I might use another color. Yeah, this one. And what you'll see is that as I set this lower, I start now recognizing my membranes as teal positive. So maybe in that case, we might not need the different thresholds. It might not be interesting in that case, so I leave it as is. And I move directly to the last stain. So this stain is cytoplasmic, so I'll go directly to the cytoplasm category, and then proceed to the same step. I probably just select the pink markup just to play with the three different thresholds. And I'll go to the first slider just to set my boundary between negative and positive cells. All right, maybe I can decrease this a little bit. Sometimes if you see some things that do not work, it might be because your membrane segmentation at first was not completely correct, but it's still all right. So you can just go back to the membrane cytoplasm detection and maybe adjust this a tiny bit more just to correct this if needed. All right, so I think this is probably a good compromise for now. Okay. All right. Okay, going back to pink, and I set my other categories as well. So this is all right for the first category. I can then move to our weak, strong, weak intensity category, moderate category, and strong category. All right. So I mentioned this percentage completeness threshold parameter. And this is basically, so this is a very helpful parameter if you have a positive cell next to a negative cell. So if I maybe go back to the cell markup, you see that now you have some cells. So if I toggle this on and off, actually this is not a good example because they are all positive. It seems to be all positive here. But maybe if I find some cells which are close to each other, all right, so probably that's in that case. So this one, I probably would say that this one is positive while this one is negative. But they are, well, actually, I don't think it's this taking into account as positive. Let's see if I can find an example, another better example. Well, I can show you what the program would do, maybe if I decrease this tiny bit more, just to create some false positive, just for you to understand what I mean. Okay, so I've created a false positive here. Yeah, I think it's a false positive. So basically, this cell would be positive, and this one next to it is taking the cues of the other cell to say that it's positive. So what I can do is set a minimum cytoplasm percentage completeness for my staining to be a minimum. Well, it would be a minimum percentage of stain to be for a cell to be considered as positive. So if I increase this now, you see that now I've increased this to 38%, meaning that now, since this cell doesn't have more than 38% of its nucleus positive, it's now not considered as positive. So this is a really good way to get rid of false positive that are close to positive cells in that case. All right, so I'll go to the phenotype now. And typically the phenotypes is to set as well to segment cells according to a combination of stains. So the first thing you can do is to give it a name. So maybe I can give it a name as doubles positive. Positive. Sorry about this. All right. So you'll then have to set a number of criteria, and typically the number of criteria would be the number of stains that are taken into account to set your phenotype. So one thing I can do maybe is leave it to 2 because we will be considering 2 stains, and you will have to set the criteria then. So the first criteria would be the DAB stain, and the second criteria might be our pink stain, for example. And you can then set the filters for your criteria. So you can set, for example, DAB stain as a positive stain, or you could even choose it to be negative or positive or negative. So these are the different options you have here. So I've set it as positive, and probably I'll set the pink stain as positive as well. So if you would want to look now at your double positive, you can go to the, you can scroll this down and go to your double positive cell, and you see that the ones which are highlighted now are only the cells which have both stains at the same time. All right. So we can go now to the advanced options, and these typically are the same in every segmentation algorithm. The first one is the minimum tissue optical density. So if I go back to the real-time tuning window and I go now on the edge of my tissue, you see that I have this boundary here. And this is basically set with this number. So if I go too low, I start picking some of the background as the tissue. And if I go too high, I will start losing part of my tissue that will be recognized as glass. So of course you want to set this properly so that you are sure that your area, your tissue area is correctly taken into account. If you had some edge artifacts, maybe some intense staining at the border of your tissue, for example, you could get rid of, you could remove the first microns of your tissue from the analysis by setting a number here. So if I set this to 5 now, I've let the program know that I don't want to take into account the first 5 microns of my tissue. And the next one is whether you want to store your object cell data. So if you want to, you can set this to true and take the please keep in mind that if you don't set this to true, when you go to your results tab, you won't get any single object data. And typically those object data are very essential if you want to maybe run a special analysis on your image, since it will need some single coordinates. So I'll leave this at true for now. And you could choose to run your analysis within a classifier or a class list. So this would be typically something that you would have previously done within the classifier tab. And that's all right. So once you're happy with this, you can probably one thing I would recommend now is to go to the last stain that you've selected and select the output image that you wish to be analyzed. Don't forget about this, otherwise you will get, of course, the last markup that you've chosen. So I probably go now to cell markup just to make sure that I have the whole segmentation in my results. And you basically have a little asterisk here that will let you know that the algorithm has not been saved yet. So I can go ahead and save it under settings actions, save and give it a name. So maybe training, and save this parameter. All right, so I probably run the analysis on the field of view. So if I select field of view now, you see that our image is being analyzed and it's being analyzed quite fast here. And if we go to the results, you'll have the summary data here and the object data down here. And remember, the object data have been generated only if you set this to true in the previous step. All right, so you have different parameters here. So you'll have your total cell counts, the number of positive cells for each of these categories. So for example, in the case of the TIL positive cells, we did not set any thresholds. So you will have only one category. But if you set different thresholds of weak, moderate, and strong, you'll have also these lines as well. And you find negative cell counts as well. You have some information about well, all these these compartments as well. So you have the same information per compartment. You have the information as percentages, your H-score that have been generated, the optical densities as well, and as well as the area of your cells. And in the object data, well, actually, one thing that is now new is that which is new to Halo 3.1, is the fact that you can pop this out if you want to, or you could even put it on another screen. So typically, I can just drag it or just double click on it, and I will be able to see all my data at once. And if you click on a cell, you'll find the corresponding data in the table here. And the same is true if I select my data in my table. I could also select multiple data in the table to select different cells also in my image. So here you have your phenotype. First of all, you have also the information about each of your stain. So the first information would be the classification, whether it's positive. Well, if you will have the moderate, strong, moderate. Sorry, the weak, moderate, and strong categories. You'll then have the optical density, and you'll have then other information about the percentage completeness if you set this to true, the cell area, cytoplasm, membrane, and nucleus area, the parameter of your cells, as well as their coordinates. And one thing you can do from here is to set this, you can sort them by size if you want. Well, you can sort them by number here. And you can also filter this. So I could look, for example, only in my DAP cells, only the ones which have moderate staining. And if I do so, then I'll have only those cells selected here. All right, so I probably now go back to the analysis tab. Do you have any question before I move on to the ISH module? You probably have to unmute yourself if you do. All right, so I guess no one has a question for now. If you happen to have a question afterwards, please don't hesitate to interrupt. There is really no problem at all. Okay, so I probably move to the ISH module now. So there are different things you can do from here that I didn't mention. You have your default settings that are here, but you could also choose to import settings that someone passed you on. Or you could go to this previously saved settings. So for example, here we've just saved the multiplex EHC training setting. So I could probably just go here and select that one if I wanted to. So I'll go back to the default settings and I go to the ISH module. So if I select each module and press select here, I'll open it here now. I'll move to the next image, which contain some staining, some EHC staining in blue, which is the teal stain here, some probe stain in red, and my hematoxylin here as well. So you'll see that this looks quite similar. And typically the first steps would be exactly the same. So the first thing you want to do is to set an analysis magnification. The image zoom now is set to 1. So we are running the analysis at 40x, which is actually recommended for ISH and FISH. So we'll leave it as is. And here you'll have the different stains. So the first one you want to set is your nuclear stain. So I basically go into my image and look for nucleus. What I like to do is I tend to not take the nuclei with very faint stain because sometimes the convolution is not really working well with that. So I usually try to go somewhere a bit darker. Yeah, and set that as is. You also can set an exclusion stain as earlier. So I won't do it for now because we don't really have anything that is that might be interfering with our segmentation. So I will leave it as is. And the next thing I do is going to the EHC stain selection, and I'd probably do exactly the same. So you have to set first the number of stains. So we have only one here in that case because we have the teal stain. So I leave this as teal. And I'll go to the color selection window and do the same thing as earlier. Try to pick an area where you only have your teal stain on its own, of course, and press OK. And what I will do now is directly jump to my probe selection. So if you're confused and you don't remember where those are, you can just look at selection. So if this is where you can basically select your color. So if I go to each probe stain selection, I can do the same. I can set the number of probes, which is only one in that case. I can set this to maybe red. And press the color selection window and look for an area where I only have my probe of interest. Try not to pick it from cells because you will have the colors of the nucleus plus the color of your teal plus the color of your probe together. So try to get it from an area where you only have your probe on its own. All right, so I press OK. And I'll do exactly the same as earlier. I'll probably just go to analyze and the real-time tuning window. You see that it's already starting to detect the cells. I'll go now to the deconvoluted image. So if you go to the teal stain alone, you'll see that it's actually doing a good job. It's recognizing my teal stain and not the other ones. The nuclear stain is being recognized. Actually, it's not very nice here because probably because the nuclear stain is quite faint. But it doesn't really matter because since we don't have so much background, when we adjust the other parameters afterwards, we can always adjust the thresholds to detect those spots here. And if I look for my red stain, I can see that I'm also picking those areas with, specifically. All right, so I can now go back to my nuclear detection. So one thing I want to do first is to go to the cell markup first. And in the nuclear detection is basically the same as what we've just seen. So the first thing you want to do is to check if you need to set a weight for another marker. So here the teal stain is an option here because it's a EHC marker. So the program lets you choose whether you want to take it into consideration to recognize your nuclei. My teal stain here is cytoplasmic, so I will leave this to 0. And you basically have the same parameters as previously. So the first one, the nuclear contrast threshold, which is meant to detect areas based on contrast with between the object and the background. So I'll first probably go to make this more transparent, just to check if this is probably recognized. And you see that there are some areas which are not recognized. So one thing I like to do at first is probably to just leave this quite low, which is the optical density, and probably the segmentation aggressiveness, sorry, a bit lower, just so I see what I can pick with my contrast threshold without any more filter at first. And I'll typically adjust this in the second step. So you see that we probably will be losing these very faint ones, and they might not be actually relevant for the analysis. So we probably leave it as is. I'll try to find the right compromise to get. So it's not really linear. You'll see that as we play with these parameters, sometimes some cells start pop in and pop out again at different intervals. So try to play with this in a way that gives you the best, maybe the best compromise. All right, so I think it's not too bad actually. So maybe this make it a tiny bit lower. All right. So typically the segmentation will always better work on images that have quite an homogeneous level of intensity for nuclei. If you have some very faint ones and some very dark ones, it's nearly impossible to get those at the same time. But you can always play with all the parameters to see what's the best, best combination. All right, so I think if I lower this, you see if I lower this too low, well, you should never leave it to 0. But if I lower this, I start getting some of the background recognized. So I can basically play with that. Okay. And typically, this would be the situation where you can set fill nuclear holes to true. It might not apply for the entire image, but I can show you what it will do. So if you have basically an area with really faint staining in the middle, you will have some over segmentation. And if you set the fill nuclear holes to true, well, now we have been losing it, but because of the strength of the other parameters just before. So probably it's because I'm losing the big objects, you see. So now I've lost it because I was not taking into consideration objects bigger than that size. So if I set this to true, you see that now I've been able to fill the holes here. But you might introduce some bias in your analysis. So really make sure that it really applies for your image and it's not introducing any bias. So maybe here I'll just increase the nuclear optical density again, get rid of this. And I think the detection is not being too bad here. I might want to go back to maybe increase the nuclear segmentation aggressiveness as it's quite low, maybe to, you see that here we are splitting a nucleus, but it's not being, well, this is not actually correct. I don't think if we increase this, it's correct. But you can always play with this, maybe lower this, increase this. So that's why I like to go back and forth between the contrast and the aggressiveness, because these two are kind of complementary. All right, so I think it's not too bad. All right, I probably leave this as is now, maybe increase this a tiny bit more, just to lose these areas. All right, so see, the parameters are exactly the same. I have not touched the nuclear roundness because all the nuclear, all the structures I'm recognizing are more or less round. and I've basically touched every of these parameters. So I'll move now to the membrane and cytoplasm detection, and it's exactly the same as before. Now, if you set a number, it will dilate out a shape, cell shape out of your nucleus. So maybe try to pick the size that fits most of your cells, which is not too bad here in that case. All right, and you could also set a stain for membrane segmentation aggressiveness, but the till here doesn't apply as a stain for membrane since it's cytoplasmic, so I leave this at false. And I'll go directly to my single stains. So here it's the same as before, but here we do not have the option yet for the 3 different thresholds. You only have one for now. And you have also these 3 categories according to the cell compartment. So you have the nucleus, cytoplasm, or membrane. You can also choose to change the color if you want. So here I'll go to the compartment that applies, which is the cytoplasm, and I'll lower this slider until I get my cells positive. All right, so we are losing this because the nucleus is not really, it's really, really faint. All right, I think this is probably good for now. All right, so I probably now move to the each probe stain selection. Sorry, to the red probe. So the selection is for the color. This is something that we've already done, so I'll move to the red stain setup. And here we have the same parameters as for nuclear detection. We have different thresholds as well. And one thing you have to take into account is that for the each module, you will take into account only the spots which are within cells. So that's why the way you set your membrane is actually very important, because depending on that, you might include or exclude some spots. So typically, these spots won't be recognized in your analysis, for example. So just adjust this as you see fit, really. All right, so we start recognizing our probes. So the first one we want to select is the contrast threshold. So it's basically the same concept as before. So this is probably too high. If I decrease this now, you see that if I go too low, I start picking any area which has low contrast with the background. And if I increase this, I will start picking this area better. One thing probably I might want to do now is to set another color, because it's kind of hard to see. And you can always toggle it on and off just to see if it's actually matching your probes. So I see that it's not too bad, but we are detecting more. Well, we are detecting some background here. So maybe one thing you can do is to increase the optical density, the minimum optical density. Well, as a rule of thumb, you should never leave this to 0 anyway. So I'll increase this and see what happens. And what you'll do is to start losing some areas with really low optical density. You can set, of course, the aggressiveness as well. So this is quite high. So this must also interfere with the way you're recognizing your nuclei, your probes. So I just increase this a bit just to select those higher contrast areas. Maybe lower this a tiny bit more. And of course, if you think this is not, I mean, this is pretty good, but you still have some speckles that you don't want into your analysis, you can always change also the minimum and maximum size. So here, you should never leave this to 0 as well, because you will introduce some background. So I'll probably just set a number for the minimum spot size to get rid of these very small, maybe background objects. So you see, for example, here we have a very small object. If I increase this, I will start losing it as well. All right. You can also just type in a number if you wanted to. And actually, these two parameters names are quite similar. You have the red spot size and well, the probe spot size and the probe size, but they're actually very different parameters. So the first one will affect how you detect your probes, while the next one will affect how you classify the probes. So by setting a size here, you're setting a reference to set the size, what should be the size of one single probe, basically. So if I make this smaller, maybe if I leave it at 1, you see that the color markup has changed. And this basically means that the small ones are counted as 1 spot, while the darkest ones are counted as 2 or more spots. So depending on the minimums or depending on the size, your reference size, your reference probe size, you will have a different way to categorize these bigger spots. And if you increase this really high, you'll see that now all these spots have been counted as only 1 spot. So this is something that you can set as you see fit. All right, and this the minimum count here is whether you want to detect your cells based on the number of probes per cell. So if I set these to 0, it means that I'm detecting all my cells. And if I set these to 2, for example, it means that in my results, I will have taken into account only the cells which have at least 2 probes in them. So typically that's one wouldn't appear in the results. So it would be taken out from the results. Right, I leave it to 0 for now. And if you had maybe some heterogeneous staining within your spots, you could also set this to true. This is similar to the nuclear holes, field nuclear holes. So I'll leave it at false for now. And I'll move to the next one. So in this next step, you can set this. You can set a cell scoring. So for example, a score of 1 here can be a cell containing 1 probe per cell. A score of 2 means that we are. It means that we will set a score of 2 for every cell which has between 4 and less than 10 probes per cell. The next one is the same. So if we have a score of 3, we are taking into account all the cells which have a minimum of 10 and under 16 probes per cell, and so on. And this will be meant for your scoring. You can, of course, change this as you see fit. I could, for example, leave it to 8 and leave this to 12. And once you're satisfied with the segmentation, you can move to the advanced parameter. So this typically works the same way. You can go onto your tissue border and see if it's recognized correctly. 0.037 usually works for most of the tissues, unless they have very dark background. So I leave it as is. The tissue edge thickness is the same. You can remove the first microns from the analysis. And you can store your object cell data to true or to false, depending on what you want. So I set this to true. One question that comes sometimes is whether you can whether your object data is for cell or for probes. In that case, it's only for the cells. So you want to take this into account for your analysis. And as previously, you will have you can input your classifier or set a class list. I'll just go back to probably to the last parameters and check if my output image is the right one. I think I haven't set a phenotype. I might set a phenotype just to show you how to deal with this. It's exactly the same as before. So you can set a name. So I will set this as double positive. Oops, sorry, I'm a bit. All right. The number of criteria is the number of stains typically. So I have 2 stains in this case, which is all right. I can leave the right. You have the different compartments. So I leave it to probably teal cytoplasm and red red here. All right. I leave this as positive, but please keep in mind that you have other parameters as well. And I leave this as positive as well. And if I go to double positive, I will now just see the cells which have both stains at the same time. So before I run the analysis, I'll pick the right output image, which will be my cell markup in that case. Probably save these parameters first. All right. And run the analysis. Maybe I can run the analysis on a field of view. Under Analyze, field of view. You can see the progress, and you see that this has been quite quick. And now if we move to the results, we have, as previously, the summary results and the single object data as well. So here you have your total cell counts, your number of probe copies, and you have some percentages according to the categories of scoring. You'll also have some average copies, number of average copies, area, and optical densities. You have the average copies per micrometer as well. Some more data on depending on the cell compartment. Your double positive, which is your phenotype, the scoring as well, and basically the same parameter as before with the area as well. And here you'll have generated different histograms automatically as well. So this is depending on your scoring. And typically we'll have the number of cells for each category, each score. And you have the number of the frequency of cells per number of probes without the scoring. And if we move to the object data, you will also have the single object data. As previously, you can just click on one cell and look at the results, and click on the table as well. And you'll have different information here. So the information about the cell area. So this depends, of course, on how you set your radius, your cytoplasm radius. You have some more data about area depending on the compartment, on the cell compartment, the cell parameter, and your positive stains here, your positive stain here, and your probe here, together with the classification. So here as well, I can classify according to my scores, and I can sort them as well. You have some areas also for these probes, and you have some information about the coordinates of these cells. Okay, so I think I've covered that part as well. So yeah, I'll ask if anyone has a question before I move to the FISH module.
Hello, thanks for the nice
Hello.
presentation.
Thank you.
Yeah, my question is, when there is a lot of expression in the cell, we often see that the dots get merged into each other. So the red size is the way to segment the merged dot.
Yes, so exactly, actually a smart idea of yours. You can, so if I go back to here, nice real-time tuning. Okay, so if you can't seem to, so you have two ways of doing this. You can either adjust the spot segmentation aggressiveness. So I can increase this or decrease this. And you can, of course, as you've mentioned, for those that do not seem to maybe segment more, you can use this size as well. So if you know what's the probe size, actually a good way to know probably is to go to your results. If you go to your results and go to your copy area, so maybe let's pick a cell which has only one probe, you will have the area of your probe. So you know that it's more or less 0.4. And you can use this data to input it here. So you know that it's even smaller. And this can be used, so I put 0.4. This can be used, as you mentioned, to divide those this information, as you said.
Could you please tell me what is again the difference between spot size and red size?
Okay, so the spot size is okay, so if I go back to the real-time tuning, it would be easier to see. So the spot size here is, you have two sliders here, and it's basically to set how your spots are detected. So according to this, you will change the detection of your spots. All right. So if, for example, I change this to maybe I don't know, 1, now everything under 1 is not being detected, and if I set this under to 11, nothing above 11 is detected. If you go to the spot size, to the probe size, I know it's a bit confusing here. If you go to the probe size, you change how the spot, how these spots are being classified, but you won't change the way they are detected. So you won't change. So you will base your classification on the markup that is already here, but you won't be changing any more detection. So within this information that is already here, now you can classify. If I want this to be recognized as individual or multi or spots with multi each probes. So if I increase this now I'm telling the program that one spot has a size of 4.5, and it means that everything that is not even double this number won't be recognized as 2 spots or more. So now I don't know if you can see that now we have a faint color here and a dark color here. So all the faint spots will be recognized as 1 spot, while the ones with a darker color will be recognized as 2 or more spots. Does it answer your question?
Yeah, thanks. Perfectly. Thanks.
No problem at all. Any more question? All right. So if no one else has a question, I move to the fish module. Okay. I can also give you maybe 30 seconds if you want to get a glass of water or something. I will just load the fish parameter for now. Okay, so fish IF and select. And I'll go now to my next image. Okay, so now we'll go to fluorescence. So probably one good tip I'd suggest is to go to view and change the skin of your interface. So what I usually like to do is to go to dark interface, as it will reduce eye strain for fluorescent images. All right, so here the fish module is basically the fluorescence version of our EHC module. And you'll see that there are slight differences, even though they are very similar. So the first difference is that we have dyes here instead of stain. And typically here, it's probably a bit more flexible because you can just choose to ignore some channels that you wish to exclude very easily, or include as many dyes as you want. So the difference here is that, of course, you have this view settings window, and this typically will be here for every image for every algorithm when you're using fluorescence. And this is to change the way you're viewing your image. So if I click here now, typically what I can do is to change the brightness of my image by decreasing this parameter here. And I can increase the contrast by increasing this parameter here, for example. And you can do this for all your channels or some channels at once. Okay, so I'll probably leave this here. And this is actually quite good if you do not have a really good, if your image is not maybe rendering really good detection, maybe for your eye, you can always change these parameters. And bear in mind that you can set these parameters as you see fit, because it will never change the way, it will never change your image, but just the way you can view it. So you can change this as you wish. All right, so here we have our channels. So this image contains 4 channels. I probably just ignore one of those because we've gone through many parameters now. So I probably just need those 3 just to show you what the program can do. And here, as I mentioned, so first of all, sorry, you can go to the analysis magnification. I tend to leave it at 1 because it will run the maximum magnification here in that case. And I'll move to the dye selection. So here you can set the number of dyes, which is different to the number of fish probes. So I can give it, I can set maybe two dyes for now, and 1 fish probe to have my 3 channels. You can of course change this with the slider, but I like to use I like to type in a number directly. All right, so once you've chosen your dyes and fish probes, you can choose them from the list. So I choose first my nuclear dye, then the other dye, and then the probe. So it's quite straightforward. This time you of course don't have to pick any color because the channels are already split. And you can set a number of phenotypes as well. So here you can set up to 30 phenotypes using this slider. As previously, this section has been populated now, and you can set a number if you wish to as well. And typically, as we've done before, I'll go to the real-time tuning window, and you see that Halo is already trying to do something because the first dye input was the nuclear dye. All right, so one thing I'd probably recommend, so when you go to your nuclear detection, is to switch, maybe to tick and untick these channels according to what you want to see or not. So typically, if I want to look at my nuclear, if I want to tune up my nuclear segmentation, I probably just go to nucleus. So the way I did it is to untick all the channels and tick the one I wanted. Or you can, of course, do this manually if you want. All right, so the next thing I probably do is to set the transparency. I like to change the color of this as well temporarily, just to create a bit more, maybe some more contrasts between my image and the markup. And I can go ahead and analyze and set my nuclear recognition. So by now, you must be very familiar with those steps because they are exactly the same as before. The first thing you want to do here is to just check if your nuclear weight is set properly. So since the DAPI has been input first, its nuclear weight, has been set to 1 automatically. So we are fully taking into account the information of the DAPI to recognize our nuclei. Since we do not have any other nuclear dye, we will leave this to 0. And we can go ahead and change these parameters as before. So we'll adjust the nuclear contrast threshold. At first, you see that 0.5 is actually doing quite a good job at the start. So I'll probably just change slightly using the mouse wheel. And yeah, I'll probably just lower these tiny bits. So it's actually quite well from the start, so probably won't need to leave to spend too long here, really. But basically you have the same parameters as before, so if you had some background, you could also remove it with this parameter. So I'll just remove that. Segmentation aggressiveness, maybe if I go to an area where the cells are more packed together, I can increase this. So as I said, this aggressiveness is kind of complementary to the contrast threshold. So sometimes if I play with those two, I will kind of go back and forth and see what's the best combination of these two. And of course, you can get rid maybe of these areas if you wanted to by changing the minimum and maximum nuclear size. So I usually like to set this to 5, and maybe set this. So if you didn't want this area to be taken into account, you could make this lower, and you will at some point lose it. Actually, I'm not even sure if this is really relevant because it's really faint. So I think this image is actually kind of a thick section. So you can use sometimes this parameter just to make sure that you focus on one plane. And for that, the nuclear contrast threshold will be probably handy because you can set the threshold higher and just get rid maybe of these objects which are in the background or a bit more far away. So really this depends on what you want to do, but I'd probably recommend, if you don't have to, probably just don't use fixed sections because we might confuse your detection. But a good way, of course, of filtering this out is using the contrast threshold and the other parameters here. Sorry. All right, so you also can set a minimum nuclear roundness, which is something I probably won't touch now. Check. Oh, so we have some parameters here. So here I can change this maybe by increasing that because we don't actually have much here. So I can get rid of this as well. All right, so we can now move to the membrane and cytoplasm detection. So as previously, you can dilate out a membrane out of your nuclear shape. So I'll probably just go back to all the channels, just remove that one, and see what's the typical cell size. Maybe if I set this to 3, right? I'm getting something that is in the range of the cell size here. And as before, you can set a dye for membrane segmentation. So here, the green one, the FITC one, is a membrane dye. So I set this to true. And I set the membrane segmentation aggressiveness by going to this area. So I'll probably just go to the channel of interest as well. All right. Maybe increase the transparency slightly bit and try to match the segmentation of my membranes to the membrane marker. All right. So I'm using my mouse wheel now, but I might need to slide this tiny bit more. Oops. It's not really picking it correctly. Maybe I can make it slower a tiny bit. I don't know if it's going to change anything, but.
Sorry if I interrupt, but is not the fixed,
exactly.
It should be true. And okay, excellent. Sorry about that.
Thank you about this. It's good. I know that you're learning. All right. So this is typical. Just make sure that you choose the right one. I was really finding it very strange that it was not picking the thing, but exactly that you spotted this correctly. Yes, I didn't select the right one as a start. All right, this is much better. All right. Okay, so if I think it's pretty good now. So I could probably go to the next parameters. All right. And here you can do the same as before, which is setting your single dyes. I probably jump the DAPI because this is to give thresholds for positivity and negativity. But the DAPI has already been used for the cell detection, so I don't really need to set any threshold for my DAPI anymore since I already have the information of my cells. So I leave this blank now and it won't be taken into account, so I can move directly to the FITC. And here you have the same thing as before. So you have every compartment and only one applies in that case, so which is the membrane compartment. And if I decrease this now, you see that now I started to count this membrane as positive according to the threshold. So I can move around and see if it fits my image. All right, it's working pretty well. All right, so I'll move to the next one. And okay, so I'll probably just go back to the image and go back. Okay, just I'm just going to set back the tape here and select only my spot channel. Sorry about this. All right, now yes. So the color markup also is quite similar to the spots marker, the spot color. So I'll probably change this as well, just to help me with the segmentation. So I can maybe make this a bit more transparent. And you see that it's already kind of detecting something. So you'll have the same parameters as before. And here, so here, these parameters are very similar to the ISH EHC module, to the only difference as the to this parameter, which is actually the same type of parameter, but it doesn't have the same name. So if you recall, sorry, if you recall in the first in the ISH EHC module, we had a spot size and a size here. But this time we have a spot size and an intensity. So it means exactly the same. So this is the intensity that is being allocated to one spot. And this is basically to recognize how to count the spots as one or multiple spots. So if you set this too low, you will have, of course, all the spots will be taken into account as multi spots. While if you set this too high, all your spots will be recognized as only one spot. We do not have a markup image, let's say markup change as previously, but you will see a difference in your results afterwards. When you will look at your number of probe counts, it will be completely different according to this parameter. So set this carefully. So as I mentioned, a good way to do this is to probably go into the results and just check what's the intensity of one spot. Maybe detect, maybe check that first and input this value here. Just be very careful not to set this to 0, because when you set this to 0, you're actually saying, tell the program that a spot has a null intensity, which doesn't make sense here. So it's very confused now, and I mean, it's still recognizing something, but has lost completely those bigger spots. So make sure that you have a value here, at least, of something. So I think 0.1 in that case was actually all right. And you can, of course, play with those parameters again. So depending on the contrast you apply here, contrast threshold, you might detect more or less. One thing I like to do at first is, as I mentioned before, is to set all the other parameters as minimum. So maybe 0 is probably too much. Well, but you'll see that if I set this parameter to minimums, I start recognizing some objects now probably from the background, but also from my spots of really dim intensity. So you might want to modulate, this parameter as well. So maybe if I increase this and set this, set a number, you see that I can change the way I recognize my spots. So I usually tend to set this quite low, but then I just refine the detection with the contrast. So if I increase now the contrast, I'll make sure that I get only the area where the spots are. And as I mentioned before, all the spots which are outside of my cells are not being taken into account. So as I mentioned earlier, you can set a minimum and a maximum spot size. So if I set this to 0.1, now I will include all these areas, but check if it's actually correct. It is in that case, and I can set a maximum as well. The copy intensity is also going to be changing the way you count these spots as single or multi spots, and the aggressiveness is going to divide them or divide these spots, or if I lower this, you should have some fusion as well. But as I mentioned, you can always go back and forth between this parameter and the contrast threshold to find probably the best compromise. All right, so this is quite good. So we'll probably move now to the scoring, so which is the same thing as before. A score of 1 means that we are taking into account the cells which have 1 spot, between 1 spot and less than 4 spots. A score of 2 is for cells that have 4 spots, a minimum 4 spots, and under 10 spots, and so on. So I can also change this as I wish. And you'll see that this will be reflected in your results. And I'll move to the phenotype. So I'll probably set this as double positive as well. I don't know what's going on with me today with the keyboard. All right, double positive, and I set a number of criteria as well. Set this to 2 because I want to consider 2 channels, and I select my first channel, which would be my 50 channel, and the other channel would be the CY3, which is my spot. So here I want the double positive, so I'll select N positive in both cases. And I can look at my markup image as double positives. So here, when you look at your markup image, you will only see the, well, the double positive will be highlighted while the other ones will be dimmed in the background. And probably before I run my analysis, I just go back to colocalization just to get everything. And if you go to advanced now, you don't have any threshold for the tissue because you don't need this in fluorescence, and you can store your object data if you want to by setting this to true, and run your analysis within a classifier or a class list as well. I just save these parameters by going to save and giving it a name. Just so you know, every time you save your parameters, they will be saved within a study file. So they will be contained within your study. All right, so I probably just go back to all the channel view, maybe go to an area of interest and run the view, field of view. Of course, you could run the analysis on the entire image, but it's a very big image, so I won't do it for the time left. And you could run your analysis on an annotation layer as well if you had set an annotation before. So this is something that is possible. So actually, I could do it now just for a change, maybe just to show you what you can do. So if we go to annotations now and select this square, maybe save annotations and go back to the analysis, I can now analyze within my annotation layer. All right, so you can see the progress here. It's analyzing this area that I've just drawn. And you see that now you've generated a markup image. So we can now go to the results. And typically what you'll see are the summary results here and the object data down here as well. So you have the total number of cells, your number of positive cells for each of your channels, your negative nuclei as well. And this will be also broken into the compartment that you've chosen to study. So in that case, the cytoplasm membrane here for FITC. You have some also percentages information for your positive cells for each category. Some intensity values, the number of copies and their areas, and the scoring as well, and the area, average area, and total cell area, of course, and your object data as well as before. And it's basically the same. You have your phenotype here, and actually that's probably why sometimes people set phenotypes, because if you wanted to, you could also not set a phenotype and just filter your data according to these filters here. But having a phenotype is a nice way of having the cells of interest in a straightforward way, and have it assigned, a name assigned as well. So you'll have all the information, which is typically the same. So the phenotype, your different channels. So the first would be DAPI according to intensity. The different, here we have 0 because we don't have a cytoplasm. Their intensity, the channels of interest, so your dye of interest, which is FITC here according to classification and intensity. The CY3 dyes, probe dye as well, the average intensity, and the area, the different compartments of your cells, and the coordinates here. All right, so I think I've covered everything for this algorithm. Do you have any question
Yes.
for this?
If I have a Z stack, so while analyzing, shall I take a maximum intensity projection and then do the analysis?
Yes, this is what we would recommend. The only thing that you might, oh, no, why did I close this? Sorry about this. I can just open it again. Yes, so you will have to, okay, if I probably just go to the DAPI. So actually this I think is a well, it's not a projection because it's not a confocal image, but this is it's a deep image. So you probably have something quite similar to this if I go back to nuclei. But the only thing you might want to consider if you do that is that you might have some, I mean, no, actually, if you are doing a zeta stack, you might have some nuclei which are covering other nuclei. So probably be careful about this because if you might create some interconnected nuclei if you do that. So you can, of course, do that, but make sure that it doesn't interfere too much with your nuclear detection, because if your projection is on a really thick zeta stack, you will have some nuclei that are covering other nuclei, and that will be really difficult to segment, basically.
I was wondering because in the result section, the software gives you the area of each cell. So if I have a Z stack based on the number of a stack and the spacing in between them, can this generate the volume of a cell rather than area?
Well, you can do this. You can extrapolate this data out of your data. This is definitely something you can do outside of the program, but you cannot actually do this within the program just yet. It's probably some feature I may talk about to our developmental team. But for now, as of now, you cannot do that automatically within the program. But you could definitely. I mean, it's definitely a good idea of yours. You can definitely do that outside by taking this data out.
Okay, my last question is that if I have a lot of image that I want to batch process, obviously I'm doing all my tweaking around with my first image, but then I can run on the whole batch, or I just have to tweak each and every image.
Well, you will have to judge if your images are actually similar enough. But you can definitely run your parameters. So if you go to, let's imagine that this is a new image. Now you can definitely go back to your parameters and load them, and you can save. You can load saved settings. So for now, for example, he had a new image. I could load these settings that I've just set. And check if it's working. And if it's working for most of your images, you can run your analysis in batch from the studies tab.
Thanks a lot.
Do you want to know how to do it? So
yeah,
I can show you if you want. So if you are in your folder, and that's why we probably recommend to always put the images that really are meant to go to the same study together, because you can run your analysis in batch through an entire folder by just selecting them. So what I just did now was just clicking and shift and click again. And if you go to right click, or you go to image actions, you will have the same, basically the same menu. And you can basically run your analysis in batch. So if you go to analyze, here you can set your analysis settings that you have already saved. So if this was the last one I saved, or you can run your analysis on a classifier. Just keep in mind, because sometimes people think that you can do either one or the other one. Just keep in mind that if you've included your classifier into your analysis, you can, of course, run the analysis onto your classifier and with your analysis settings within the analysis settings. So you'll select that and then select which parameter you want to set, and just press analyze. And this will basically run your analysis with the same parameters on every of your images.
That's great. Thanks a lot.
No problem. Anything else?
Hi. Yeah. Yes, hi, it's Simone here. Thank you very much for a brilliant presentation. I really, really enjoyed it.
Oh,
in the context of so it's basically, of course, it's more specific on my needs, but in a concept where you have a tumor within normal tissue, you want to analyze the tumor, of course, you need to run, first of all, a algorithm to identify the tumors, and then run the algorithm that you want to count the positive cells for certain sort of staining. Is it possible to run those two algorithms together on these on the image and prioritize which one doing first, for example? You see what you want to
Well,
say?
the thing you can do, I think this will answer your question. So you can definitely set, I just go back here. So let's imagine that, for example, this was my tumor and the rest was the stroma. I could definitely classify this as first, save my classifier.
Yeah.
And then when I run the analysis, I'll just go to advanced and pick the classifier I've just trained that you would have saved.
Yes.
And basically what it will do is when you press analyze, once you press analyze, it will classify your image first and then apply the analysis on this classifier. And of course, you can set your class list as well. So you can set your classifier, but also choose the class you wish to study. So if you wanted to study all classes together, you just wouldn't have to set a classifier. But if you wanted to only, for example, run the analysis on the tumor, you could select the class list and select the tumor class only.
So, for example, if I have different type of organs, I have or different tissues. So you have like the pancreas, you have like fibrotic tissue, you have like stroma, and so on. I can classify all those tissues and then see in each one of tissue what results I have based on the algorithm that is set up in base of the staining.
Exactly. So when you will go to the results, you will basically have the information per class.
Per class, yeah. Okay. And then those results can be exported in like Excel, something like that, and then digest on other software for stats and things like that, I imagine.
Sure, you can definitely do that from here. So if you go to your image, for example, or multiple images, if you go to if you right click, you can export different types of data. So you can definitely export your summary analysis data. So if you recall, the summary data are all those data here. So you can export them by going to export summary analysis data, and this will be an Excel sheet. You can also export all your object single data. Well, annotation measurements, we didn't really show this today. Or if you really want to customize the way you export your data, you can go to advanced. And here you can create a folder that will contain images, numerical data, so all Excel sheets that you need.
Yeah, I think they showed it as well. Okay. Yeah, thank you so much. Yeah. Last, I think probably has been just shown already, but when you did the annotation, is it possible to also like automatically create 6 random annotation and then analyze them?
Yes. So you can do it. So let's see. I'll probably just remove it. Okay. So let's take into account this annotation, for example. So I'll just click on this. Oh. I don't know why I'm also picking my, okay, so if I select my annotation now and right click, okay. So if you go to the advanced option, so you have some fancy, let's say, tools here, and you can, for example, tile this area if you wanted to. Okay. So for example, if I click here, I can I can kind of make a grid here. And of course you can change the grid size. So maybe I can give it style size of 50 microns. I can set a space between them, and I can even make it random. So so random reduction. So if I now set a randomness, now you see that this is random, being random.
Yeah, excellent. Yes, this answers my question. Thank you so much.
Sure, no problem at all.
Thank you very much for being very kind. Thank you.
Oh, thank you. No problem at all.